Hello everyone.
Hello.
Hi Rohi. Uh, I'm not sure. I believe others will join by 8:35, right? So let's just wait for some time because I did inform I'll be 5 minutes late, but I was able to join on time. Let's wait for some time and then we'll give it a start. Okay. Yeah. So let me just keep my screen shared. Okay. I think maybe we can give it a start. Yeah. Let's other people join. So we will continue from where we had left out yesterday. Now let me just check what was the last command I had, which was this. So I was selecting the grade and count of courses as number of courses from the enroll table where the student ID is greater than a certain value. Then I'm ordering it by the number of courses and then grouping by it. This query is wrong as we discussed because we have to group it by first and then only we can go into the order by. So the ideal way to do this or one of the ways to do this will be this, or we can also use order by and then the name of the alias. So that's what we have discussed yesterday. So today we are going to look into some very important concept. So that's why I was waiting for others to join, but let's give it a start because anyways we will share the videos. So the concept which we are going to look in today is that of joins. So let's try to understand how exactly joins work. Let me just take my pen. Give me 1 minute. Here. Why is this not working? It's really difficult. Sometimes the Zoom controls are really very annoying. Give me 1 minute. I think my Zoom screen has hanged while I was clicking on the annotate option. Give me 1 minute. Yeah, I think it is fine. No, it's still not opening. Man. I don't know why. Yeah, this should work. Yeah, okay. Okay, so let me just take the pen. Yeah, I hope now it should be visible. So there are, if I talk about joins, okay. So if I talk about joins, okay, there are four kinds of joins. Okay, four major kinds of joins that we have. So first of all, let's try to see what exactly is join, and then we can look at how joins are done. So how we do joins or why we do joins is because let's take an example. So this is something that we are going to fire as a query as well. So I would just like to know, okay, I would just like to know what is the average GPA, okay, of students. So I have the students table where I have the GPA, right? So there is a column which is GPA of students which are enrolled in each course. So I have this enrolled table as well. Okay, so I have an enrolled table where I have the mapping of course ID and the student ID. So I have student ID, I have course ID. I have this mapping already in this table. I want to know what is the average GPA per course ID. Okay, so GPA is here and course ID is here. Okay, so GPA is over here. So this is table A, this is table B. How I combine the output of these two columns is by making use of join. Now, clearly, if I have to join the data, there are certain options that I have to consider. First of all, I have to consider the semantics. I mean, how do I really join? Okay, to join this, I need some kind of a key. Key field should be there. Okay, so some key field which is here, let's say K1, and some key field which is here, which is let's say K2. Okay, this K1 and K2 should have similar values. In this case, is there anything which is similar value? The answer might be yes, because in this case, the students table also has the student ID, right? And the enroll table also has the student ID. So this becomes my key of joining. So you need a key. You need some kind of a key. If you don't have a key, you have a mess. But then that's going to result in a very difficult kind of a join. But that is really not going to be called as a join. We are rather going to call it as a union, because and that's a different kind of, let's say, operation when it comes to SQL. But when it comes to join, it's just like you have this table with I think students table. Our students table has 5 columns. Maybe I'm going to select only one column out of this, but it has 5 columns, and this enrolled table, I believe this has 3 columns. Okay, 3 columns. Sorry, let me just do a Control Z. So it has 3 columns. Okay, so if I do a join, ideal condition, if I select all the columns by doing a join, it should select all the 8 columns which are there in both the tables. So 5 columns from the first table and then 3 columns from the last table. This is ideal condition. So I'll have to write the names of columns for each and every table, and then I can do this. But then I can also selectively do it. I can select the columns which we really need, and we ignore the columns which we don't need. In this case, I need only the average of GPA. So I'm going to use an aggregate function AVG, right? And then I need the course ID. So I can select the course ID from here. But Maybe at a later stage this can get extended, and I'll tell you how this can be extended. But overall, or a very simple kind of an example will be, I'll select the average of GPA from this table and course ID from the enrolled table. And once I join the final table, the final output, if I may say, is going to have two columns. One is going to be the average of the GPA, average GPA per course ID, right? So per course ID, what is the average GPA? This is what I'm going to have, right? Now the type of join, which is, as I said, there are 4 types of joins. The type of join is going to determine actually as to how many or how the rows will be represented. Okay, the columns are in my hand because I can do that select column 1, column 2, column 3, and so on, right? But the rows are with respect to how I'm going to join these two tables, right? So that's where there are 4 kinds of joins that come into picture. Okay, 4 kinds of joins which will come into picture. Okay, first one is known as left join. Other one is known as right join. Third one is known as inner join, also known as equi-join. And the fourth one is known as outer join. Okay. That outer thing can also be called a full join or a full outer join. This is also called a full join or a full outer join. Okay. Why? Because this left join is also known as the left outer join, and the right join is also known as the right outer join. Okay. So we will see why these are the names and in which cases we can really use this, right? Let's just try to quickly look at this, and then we will see what are the use cases in which we can actually derive it ourselves as to what kind of uh, use cases there might be. So clearly, in case of a left join, what is going to happen is, in case of a left join, what is going to happen is, I have a table here. Okay, sorry, I have a table here and I have a table here. Let's say these are my 2 tables. Now the best way of representing this is this. Maybe I can save time. Let me just do one thing. Let me clear all the drawings and close this, and let me stop the sharing and let me share a web page. I believe that's really going to be helpful. Give me 1 minute, Rohi. Let me just share a web page. I believe this is really going to be useful, and you can clearly understand what is going on over here. Okay, so yeah, I think this page should be good. Let me just share this. Where is, it's just to ensure that I'm not drawing it in a right or a wrong way, because when I draw it depending on my mouse, it's not going to work properly. I hope you can see the screen. Let me just get rid of this. Yeah, so how these joins are working is, on the left join, what is happening is, I select all the columns or all the data which matches on the left table as opposed to the right table, right? On the right join, I take all the data from the right table, but only the matching rows from the left table. Okay, we will come to know how this is working, so don't worry. So as of now, to read this diagram, what we can do is that whenever there is a blue line, okay, that's the matching criteria. That's the primary. Okay, primary in the sense that's from where all the records will be selected. If you have a left join, then you select all the records from the left table and the data that is matching between left table and the right table. You see over here what is happening here. You see this part is the left table. Okay, this part is the left table, and this part is the intersection of left and right table. Now let's try to define what is a left table and right table. That will help us understand what is going on over here. So when we write join conditions, right, we are going to write it something like this. So select something 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 from table T1 and table T2, where T1 dot some key K1 is equal to T2 dot some key K2, right? So this is going to be my query. So in this case, what is going to be my left table? My left table is going to be T1. My right table is going to be T2. Why? Because simply put, in the conditions, right? In the conditions, when I was writing the from clause, I have written the T1 table first and then T2, and then also in the where clause, this is main. In the where clause, I have written T1.K1 first on the left side and T2.K2 on the right side, right? So left hand side of this equation that I have highlighted is my left table, and the right hand side of the equation is going to be my right table, right? So keeping this in mind, my left table in this case is going to be T1, the right table is going to be T2. If I do a left join, which I have not done over here, okay, this is just a syntax. Okay, this is just a syntax. This is just a syntax to show you how join can be done. Okay, this equal to sign actually represents an inner join, right? Because I am doing an equal sign without any other operators clearly means an inner join where only matching rows, whatever is matching or the common rows between two sets is going to be resulted. So this is clearly this entire concept has come out of set theory. Okay, so you have two sets. If you're doing a union B or a intersection B, this is what you usually do, right? So that's exactly what we are doing in this case as well. Okay, so left table in my case is T1, right table in my case is T2. Okay, T1 is the left table, T2 is the right table. If I do a left outer join, what I need is to, for the cases when I need data, all the data from the left table and matching data from the right table. What about the rows which are not matching? From the right table, they will be represented as blank values or null values. How do I represent that? If I need a left join, I'm going to put a plus sign on the left table. Okay, so if I write a plus sign here, so T1.K1 plus is equal to T2.K2. So it will look something like this. Okay, T1.K1 in bracket plus sign is equal to T2.K2. I can even write it as text as well. Okay, ANSI SQL supports this kind of syntax as well. T1.K1 left join with or left join T2.K2. Okay, so dependent on, or let's say depending on the database that you're using or which version of ANSI SQL that database is using, which is clearly visible or explorable from the documentation of the database, we will be able to find out what's going to be the exact syntax here, but we can clearly write it in English as well. So plain and simple English, T1K1 do a left join with T2K2, right? So T1 table getting joined with T2 as a left join. Why? Because I need all the rows from T1, but I need only matching rows from T2, joining on the keys K1 which belongs to T1 and K2 which belongs to T2, right? So if you have understood this, then the rest are exactly in line with wherever the blue light is. Okay, in this case, in case of a right outer join, I need all the data from the right table and matching data from left table. Wherever there is white other than inner join, okay, inner join is a special case. Other than inner join and full join, we have left join and right join where there is one big section which is in white colors. Okay, so in the case of left join, I have this left table and intersection of left and right table in blue. This will be part of the output. This will have the data. Whatsoever is part of this white section and part of right table is going to be empty values or null values in the output. Same applies here. Left table, this portion which is not the intersection with the right table, but part of left table, this will be null values. And whatever is the intersection, okay, whatever is the intersection and the data which is there on the right table is going to be filled with the values. Now what happens in inner join? We select only the common values, right? The query that I have written over here where T1 K1 is equal to T2 K2 is the example for inner join. Obviously you may have already guessed, right join is going to be T1 K1 is equal to T2 dot K2 plus sign, right? Or it can be written as T1 dot K1 right join or write outer join or write join on. It actually depends on the syntax of the DB T2.K2, right? So this is how we can write the left outer join syntax, the right outer join syntax, and so on, right? In case of full join, what we are doing, this is a very special case, not really very useful, but in some cases it is really useful. So what we are doing in case of a full outer join or full join is that obviously I need the intersecting data, but I also need the contents of left table and the right table whenever there is no intersection as well. So even if the data is not matching by means of these keys, I need it in the output. How do I do a full join or a full outer join? I write a plus sign on both sides. So T1 K1 plus is equal to T2 K2 plus is what we are doing, right? So this is how joins are going to work. I would share some links so that you can get some more examples, and this page as well I'm going to share so that you can understand how it is really working there. But let's go back and let's just take some examples of what we can do. So our example uh, is going to be the same question that we are going to answer. So we are going to get the average GPA of students enrolled in each course, right? So I'm going to write this as select. Obviously, the first column is going to be average GPA. Rather than writing GPA, and in addition to show you join, I'm also going to show you something which is known as table aliasing, okay, or table naming. So I'm going to say s.gpa, okay. Please hold on right now and you will come to know what this S dot means. I'm just going to call this average GPA. Then the second column I need is course ID from enrolled table. Rather than writing CID, I'm going to write E dot CID as course ID. From enrolled E, student S, where E dot course ID is equal to, or no, E dot student ID, we said student ID was the common key. So E dot student ID is equal to S dot student ID, right? Now why is this not working is because let's see what mistake I have done. Okay, maybe in MySQL it accepts as this. So let me just try this. No. Oh, sorry, extremely sorry. I've used a, this is really very bad of me. I've used a aggregate function. I've not used group by. Group by a dot cid. Unknown column. Oh, sorry, e dot cid. What am I doing? Right. So this is what is the output. Average GPA per course. So for course 1, average GPA 3.7. For course 2, average GPA 3.9. Course 3, 3.5. Now, how do I beautify this? Let me beautify this first. And then I'm going to explain you what this S dot E dot and all these things mean. So I'm just going to use a round function and I'm going to pass a value of, let's say, 1. And if I just pass this over here, it's going to give me an output which is now a bit better looking than the previous one. Because now the average GPA is being represented with one place decimal after the decimal or the dot. And what that S dot or E dot means is basically I've given an alias of E to the table enrolled and an alias of S to the table students. This is not useful in my case. Okay, let me just show you what happens if I don't do this. Okay, let me just remove all these things. Okay, if I just remove all these things and I'm going to write students over here and I'm going to write enrolled over here. Okay, and I'm going to, sorry, what happened? Why am I not able to? Okay, so let me just clear the screen and sorry, let me just log in once more. I'm not sure why it is. It was not working. Something happened to my putty screen. I'm sorry for that. Sorry, Control L. Hmm. Okay, the shortcut which I use to clear the screen, if you are using putty software, is Control L. Okay, so Control L is going to clear the text in the screen. Let me just go back over here. Okay, the join is gone. Okay, very good. Let me just copy it. Can I copy it from the previous statement? Yeah, I think I can. So let me just take this query. If I just select the line, right, it gets copied, and I can say shift insert, and I will be able to paste it. So let me just now show what happens if I just remove this. This I'm going to call students. E I'm going to call enrolled, and here I'm going to remove the table aliases. Okay, let's see if this is really going to work or not. Okay, so let's just remove this. Okay, and see if this is working. The answer is yes, it is working. But then the question is, why did I really use it? Right? Why did I really use it there? Is there any reason why we need to use table aliasing? The answer is yes. Answer is yes when you have or when you want to select multiple columns, okay, which are common in both the tables. Okay, that's where the problem is going to come. If let's say CID is a column which is present in both enrolled and students table, which is not the case in our case, that would have been a problem. Let's check this. Student ID obviously is present in both the tables. That's our key, right? So let me just replace course ID with student ID, replacing C with S. Now see, it is giving me an error. Column SID in field list is ambiguous. Why is it ambiguous? Because the query, when checking for the syntax and the semantics, right, as I have already shared, the basic checks that the DB does is the syntactic check and the semantic check. When it is doing this, it is complaining that I don't know what is really happening over here, because I can see as per the metadata of the database, SID column is present in both the students table as well as the enrolled table. Which SID are you looking for? Are you looking for the one on the left side? Are you looking for the one on the right side? I don't know that. Hence, I'm getting confused. You have to tell me from which table you need this. This is where, okay, this is where you really need, okay, this kind of table aliasing. So I can do S dot, okay, and I can replace students and enrolled, because I'm going to mark them as S and enrolled as E, okay, and then I'm going to call S dot SID, and average GPA I'm going to call S dot GPA. Okay, now I have this, although this does not make any sense because I have only one student, right? So if I do a select star from students, I know that there is only, okay, there are no repetitions here itself. So, right, but only the matching things are there. So this is a good example actually, because why we are seeing only these two users, or maybe even better, why not group by s.sid and s.name? Okay, let me just add the s.name as student name. Okay, so if I add this, I can see a very good example of inner join. Why is this a good example of inner join? Because only Rohi, Saransh, and Shuddha are these three students who have relevant courses or entries of relevant courses which are there in the enroll table. I did not enter anything with respect to Mugdha or with respect to Anna, right? So that's why this is a good example of equi-join or inner join, right? Where we are only selecting the required columns as I've selected from both tables, left table as well as right table, where I have matching rows with respect to the key. What happens if I change this to right outer join? Okay, let's see if I do a right outer join. If I do a right outer join, it is not accepting it. Why? I think that right outer join is not written like this. Let me just see the syntax. Okay. What error is it giving? You have a syntax group by is okay. If I what happens if I do a left outer join? Let's see. No, I cannot do a group by. Why cannot I do a group by? Uh, I think I'll have to check this. Let's say if I write in case of this left outer join with, let me try left outer join with. If this also does not work, then I'm going to look for Google. Okay, let's look for Google. Okay, so I'll share my screen once more. Let's go to Google and check the MySQL documentation. MySQL version 8. Left outer join example. Okay, so let's see what mistake I was doing. I thought I did it right. Order so left join and using. Okay, so this is the clause. You see using. Okay, so this is how they are doing it. Very good. So what I have to do is, let me just go back to my screen and reshare my screen there. Okay, and then what I can do, let me just clear the screen and okay, so this will be left width clause should not be there. Left outer join S. Okay, E left outer join S on SID. Right, this should be the right syntax. This is also not working. Let me just quickly check back. Okay, so what it is saying is I need students S, and on this side I have to write enrolled E. You have an error. It's still throwing an error. Why? Let me just look at this example once more. Yeah, properly. Let me look at this example because I did not click on the link. Let's see what it says. So let me just share this page now. So let this page load. What is this saying? What is the syntax? Okay, so select list from table left join T2 on join condition. So that's what I've done, right? What is the mistake? Where? Yes. Okay. So okay. So this is what it is asking me to do. So customers left join orders. Okay. Let me just go back to my query. I'm not sharing my window right now. Okay. So s.sid is equal to e.sid. Okay. Sorry. Left join. Outer should not be there. Left join. Left join. Left join. Why is it not taking this one? So select from this left join order. So okay, left join orders. Oh, so that's exactly what I've done from enroll east to. Oh, okay. Sorry. Shit. This is very bad mistake I did. Really bad mistake. Very simple and silly mistake that I have. Very simple mistake. Okay. So let me just share again. Okay. So let me just clear my screen here. Let me again paste it over here. I was doing a mistake over here only. I was writing the table names using comma and then again I was doing a left join clause. So the right syntax as per MySQL doc or that help page which we saw is something like this. I'm selecting the columns and then I'm aliasing them from table T1, which is my left table, left join the right table on s.sid is equal to e.sid. Right? What happens if I run this? If you see, I'm getting the exact output as the equi-join. So this is how MySQL is treating it. Let me see what happens if I change this to E. The output remains the same. So it is basically giving left join of enrolled, right? So everything from enrolled and the common fields. The null fields are not represented. I believe the null fields will be represented if I do a full join. What happens if I do a full join? Okay, I believe this should be full outer join. No, let me just check the syntax for full outer join. So I'm just showing all of these things to you because this is how you can figure out. Okay, this is how you can figure out what the syntax is going to be for each and every database, because it's not going to be the same. You see that plus sign things that I was using, right? It's commonly used when it comes to when it comes to the Oracle DB, right? And then I've also found one more thing which I'm going to share you right now. So that's really something useful that I've found. Let me just share this page. This is really interesting. So I hope you can see it. There's a user who wants to do a full outer join in MySQL. That is exactly what I am also trying to do, right? But he's not able to do so because we don't have full joins in MySQL, right? But you can try to emulate them. So to emulate them, they are using this union clause. We don't know what is union clause right now, hence we won't go in this detail. But only left join and right join is actually possible when it comes to MySQL database. So this is a difference between MySQL DB and let's say the Oracle DB. In Oracle database, we can do full outer. Okay, it really supports it. But let's then see what happens in case of right join, right? So I've done left join. Left join I have done. Left join comes to be exactly equal to the equi-join thing, which makes sense because in MySQL, how it is showing it is left table and the common things, right? So left table and whatever was common between left and right. Nothing from the right table. That was the meaning of that diagram, right? So there is no null in the nothing is shown in null over here. So what happens if I do a right join? Okay, what happens if I do a right join? Okay, if I do a right join, now you see what is happening. It is giving the details even of the students who are not enrolled in a course, right? So the first output, if I'm doing a left join and my left table is enrolled table, then I'm getting a list of students who are at least enrolled in one course, right? Who are at least enrolled in one course, which in my case will be Rohi, myself, and it will be Saransh, right? But if I do a right join, on the right side, my table on the right is the students table. If I do a right join, then I get all the entries from the right table as well as the matching ones from the left table, which means students inclusive or exclusive, irrespective, right? Irrespective of whether a student has enrolled in a course, the output is going to show me all the records, right? Full outer join is not really possible here. So MySQL does not support full outer join. So we are not going to look into that right now. We will look into things like union and so on, right? And that we can look into. But there is one more thing which I wanted to show before we make a close for the day. There is one other thing that you can do, which is a very unique feature when it comes to MySQL. There are other databases also where this can be done. I mean, any RDBMS really supports this, is that we have this aggregation function in this case, which is my average of SGPA. Okay, it is represented as ABG underscore GPA, right? So what if I would like to show this output, this output that I'm seeing over here has all the details because I've done a right outer join. What if I just want to look at those records where the average GPA is more than 3.5. So I can do that within my where clause itself. So I can just say where AVG GPA, okay, is greater than 3.5. Sorry, it needs a space. Okay, so I just have where, oh, sorry, my bad, my bad. This should be and. Average GPA is on clause. Okay, why is it not working in case of a join? It should work in case, okay. Will it not work in case of a left join? Let me just see. If what happens if I do, what if happens if I do like this? Let's try this. Okay, let's see if this works. Where e dot si and avg dot gpa is this ever, okay, unknown column avg gpa. Very good. And let me just replace this with my function, which is this one. So my function is this. I'll just copy this and paste it over here. Invalid use of group function. Okay, so maybe there is some other way. Okay, let me see if there is some other way. No, no, there is, this one is also not working. What if I just remove this? Okay, what if I just remove this and go to the end of the query and say having having insert greater than 3.5. Now it gives me the output. So basically, I'll again go back to my right join example. Having insert greater than 3.5. Okay, AVG GPA is okay. Sorry, this syntax should not be used, right? So and should be removed, and now it should work. Okay, why did this work is because there are different kinds of representation of using that aggregate function. So this clause that we have used over here, right, having, okay, I intentionally tried out all the options so that I can show you which one works, which one doesn't. Having is an option which is quite common in many of the databases. We see it is common in MySQL. When we later go into Oracle, we will find it there as well. It's a very common option where if I have an aggregate function, okay, or I have an aggregated field, I can use filter conditions on the aggregated fields, part of the query, right? I can also do something like this, less than equal to 3.5. Okay, then I'm going to get just the opposite of this set, right? But to do that, I need to use having clause, and having clause comes at the end of the query. That's what I wanted to show you. So first is group by, then I have order by, then I have the having clause. So group by is a mandatory over here. Okay, without group by, this query will not run. Why? Because I have these two columns. One is the student ID and the student name, on which I have to group and give you the aggregation of average GPA. So I have to use group by. Group by becomes mandatory. But order by, right? Order by and having clause are not mandatory. Okay, so let's say in the previous example, when I was looking at greater than 3.5, I can do an order by here. Okay, order by AVG GPA disk. Okay, if I do that, it is saying there is a syntax error. Why? Because I have to write the order by at the end. AVG GPA space describe. Unknown column on. Okay, AVG GPA it is not taking. Sorry, AVG GPA. No, it is not taking. No, alias it is not taking. No, why? You have some problems in your. Okay, so order by. Oh, sorry. Where is that AVG GPA in on clause? Oh, sorry. Again, that same mistake I did. The problem is here, I believe. Yeah. So this is something that I need to remove. The moment I remove that extra or error where clause, right, everything comes fine. Now this order by is something which I have used at the end, and I've done a descending order. Let me just see if the alias works over here. Average GPA. Yeah, it works. It works. But order by has to be used after having. Okay, order by has to be the last. So first of all, it will be group by. Group by is, let's say, mandatory. Then I have having clause, and then I have order by. So group by becomes mandatory because I'm doing an aggregation, but having and order by are optionals. Okay, this is quite the same in case of, let's say, Oracle DB as well, right? I think we can make a logical stop here because the next areas will be more focusing on some other aggregated functions and so on, right? So we are going to look at maybe string operations we have looked, and then we are going to look at some other string operations by tomorrow, and then we can continue from there. I think I can stop the sharing. Thank you so much, Rohi.
Okay,
Thank you.
thank you.
Thank
Good
you.
night.